You probably know how cars are made today. Robotic arms, sensors, computers. But have you ever wondered how it all began? How steel, sweat, and human hands built the very first assembly lines, and how that process evolved into the machines that now build themselves. Let's go back to where the story of modern manufacturing began, to the rooftop factory of Fiat Lingotto, 1931. Steel presses echo through the vast halls of Fiat's Lingotto factory. Raw metal sheets are pressed, shaped, and riveted into form. Engines are hoisted by chain and pulley, aligned by hand and eye. Men in oil-stained coats fasten bolts, hammer frames, and pour sweat into motion. Above them, 5 floors rise toward daylight. A vertical assembly line. At the top, a concrete track curves into the sky. Cars are driven out of the factory itself onto the rooftop for their first test run. The Fiat 501 climbs the incline, roaring under the sun, proof that human labor and engineering ambition could coexist in steel. This is how cars were made, by precision, born of muscle. 2 decades later, on the other side of Europe, the Soviet Union had built its own vision of industrial power. This is a 1953 automobile factory, where metal, labor, and ideology fused into one purpose: production. The process begins with raw steel frames, the skeletons of what will become military and civilian vehicles. Machinists carve, drill, and polish every component by hand, surrounded by the rhythm of hammers and presses. Welders then join the heavy body sections, sparks flying in dim factory light, giving shape to the car's foundation. Step by step, the chassis moves forward. Engines are lowered into place by cranes, suspensions mounted, and workers tighten each bolt with muscle and precision. Soon, the bare frames turn into recognizable machines. Every vehicle assembled here, like the GAZ 69 utility truck, is built for endurance, designed to serve in the harshest conditions. Above the production line, portraits of Lenin watch over the workers, a reminder that this was more than manufacturing. It was a national mission. As the final row of finished vehicles stands ready for testing, this factory reflects an era where progress was measured not in automation, but in hands, steel, and collective will. By the 1960s, car production had reached an entirely new level of sophistication. Factories were no longer just workshops. They were vast, synchronized systems of men and machines. Here, workers begin by mounting the mechanical heart of each vehicle, the engine and drivetrain, onto the chassis. With precise coordination, each bolt, wire, and connection must fit perfectly before the car can move forward on the line. As the process continues, technicians add structure and strength. Metal frames are welded together, sparks flying as raw steel slowly transforms into something recognizable, the skeleton of a car. Grinding and shaping follow, smoothing the body and preparing it for perfection. In long, illuminated halls, the nearly complete shells glide past rows of workers who inspect, align, and fit panels with mechanical accuracy. Gigantic presses stamp steel sheets into doors and hoods in a single thunderous motion, the sound of modern industry at full power. By the late 1970s, the Soviet Union had mastered mass automobile production on an industrial scale. This, the Volga automobile plant in Tolyatti, was one of the largest car factories in the world. Here, each vehicle begins its journey suspended above the workers. Teams install suspension systems, transmissions, and brake assemblies. Every part engineered for endurance on rough Soviet roads. The conveyor never stops. Cars glide overhead while workers below fit steering columns, axles, and wiring, each task timed to the rhythm of the moving line. Compressed air tools hiss and click, tightening thousands of bolts with mechanical precision. It's a fusion of manual labor and automation, a coordinated ballet of steel and human focus. Men and women work side by side, ensuring every system functions before the car advances to the next station. Finally, the polished bodies descend from the conveyor, gleaming yellow, red, or white. In the early 1980s, Mercedes-Benz entered a new frontier of automotive engineering, where innovation met computation. The age of the digital car had begun. Designers and engineers no longer relied only on clay models or intuition. Every curve, every panel, every structural joint could now be measured, analyzed, and perfected through computer precision. At first, the concept existed only as green lines on a screen, a wireframe model representing the car of the future. But behind those lines was a revolution, the integration of CAD systems and automated measurement tools that allowed engineers to simulate forces, impacts, and wear long before a prototype touched the road. Every frame was tested, electronically, mechanically, and mathematically. Stress simulations revealed how the steel would deform, where safety would hold, and where it would fail. Sensors, test rigs, and control computers turned the development hall into a living laboratory. In the late 1970s, the Soviet automotive industry entered a period of refinement. Precision and endurance became its defining goals. At the AZLK Moskvich plant in Moscow, production lines carried a palette of bright, sturdy cars, symbols of a modern Soviet city on wheels. Above the workers, steel frames glided along yellow rails, carrying the green and silver bodies of the Moskvich, suspended, almost floating, through clouds of welding smoke and the glare of fluorescent light. Each vehicle began its life in motion, moving steadily as workers fitted transmissions, engines, and suspension systems by hand. Every connection was manual, every movement deliberate. The strength of the car relied not on automation, but on the precision and rhythm of thousands of experienced hands. Below the humming conveyor, teams installed axles, brakes, and steering components. Each step measured, each bolt double-checked. It was industrial choreography, a ballet of motion, metal, and muscle. In these moments, Soviet industry wasn't just producing cars, it was building reliability itself. Once the final bolts were secured, the cars rolled off the line, polished, aligned, and ready for inspection. Headlights flickered alive for the first time, their beams slicing through the oily air of the factory floor. The workers' faces reflected a quiet satisfaction. This was their craft, their discipline, their contribution to motion. Raised platforms lifted the finished Moskvich models for a last technical check. Engines revved, meters flickered, a final nod from the inspector, and the car descended to the ground, ready for its journey beyond the factory gates. Outside, the scene changes. Snow replaces steel. On the proving grounds, drivers in helmets steer the brand new Moskvich through icy tracks and frozen wind. The tires carve perfect arcs into the snow, engines humming steadily against the silence of winter. Inside the cabin, the steering wheel trembles, the gauges vibrate. Every sound is studied, every movement measured. This is the final examination, a trial of endurance, a test of Soviet engineering against nature itself. In the 1990s, Toyota's factories represented the next chapter in global automotive evolution. What Mercedes-Benz had pioneered in precision and what Moskvich had attempted through human discipline, Toyota transformed into a science of efficiency. Inside the assembly hall, robotic presses stamp sheets of steel into the car's skeletal structure. Unlike the heavy manual welding and hammering seen in 1970s Moscow, these machines operate with millimetric accuracy. Each movement digitally timed, each weld identical to the one before. The rhythm of production is faster, quieter, more exact. A new era where automation replaces exhaustion. Twin robotic arms close in from both sides, welding the Camry's frame with synchronized bursts of light. This level of automation contrasts sharply with the Moskvich plant, where human workers once tightened bolts by hand beneath dangling car bodies. Here, the machines repeat their tasks tirelessly, ensuring structural strength and consistency that human labor alone could not match. Once the metal skeleton is complete, human technicians step in, no longer builders, but controllers and inspectors. They adjust the interiors, route wiring harnesses, and check alignment using pneumatic tools. Unlike the Soviet and early European lines, Toyota's philosophy integrates human intuition with robotic precision, the core of what became known as the Toyota production system. Further along the line, entire door panels and dashboard assemblies are prepared. Every part has a barcode and build sheet, a concept that simply didn't exist in Moskvich's analog age. Each symbol on the production chart corresponds to a model variant, color, and configuration, information traveling instantly through Toyota's internal network, guiding every motion on the floor. By the time the dashboard and steering mechanisms are installed, the car is more than half complete. In this era, Toyota didn't just build cars, it redefined manufacturing itself. creating a benchmark that would reshape the global industry for decades to come. Each completed Camry leaves the line, headlights on, reflecting the ceiling's light like polished glass. The process feels almost meditative. No waste, no chaos. Toyota represents the evolution of industrial philosophy, order, efficiency, and quiet excellence. It's the bridge between the human touch of the 20th century and the automated elegance of the 21st, where Volkswagen will soon take the stage. In the heart of Wolfsburg, the iconic Volkswagen plant rises beside the canal. Vehicle bodies glide above the factory floor, carried by ceiling-mounted tracks that resemble arteries feeding a mechanical organism. This is no longer the rhythmic choreography of human motion seen in Toyota's lines. It is a synchronized symphony of steel and software, guided by algorithmic timing rather than human instinct. The manufacturers are so proud of the factory that they even made a production museum in Dresden and named it the Glass Factory. There, you can learn the basics and join the grand production process. It is the same philosophy, but now mediated by code instead of intuition. Where Toyota balanced human skill with process, Volkswagen now integrates the worker into the digital system. Each action recorded, analyzed, optimized. Every day, about 12,000 parts are delivered to the factory for each car produced. Delivering such a quantity to the city center could have turned out to be a nightmare. But the factory has resourcefully inserted itself into Dresden's city streetcar system and started a freight tram. The freight tram runs 7 times a day through the center of Dresden to the warehouse. It delivers 80% of the parts, except for the bodies. They're too large and too wide. The transition from Toyota's semi-automated discipline to Volkswagen's full robot orchestration marks a turning point. The parts that reach the factory are distributed via a 1.5-kilometer-long conveyor belt. This is aided by the coordinated activity of robots moving in complete silence. 57 computer-controlled carts move thanks to 100,000 magnets embedded in the floor. Like a roadmap, they allow the carts to move around the conveyor belt and even drive into the elevator. This is where the internal parts of the machine are located. The engine, the chassis, they are ready for the body to be attached. At the Wolfsburg plant, they don't play to the public. They just operate with mind-boggling numbers. Most of the work is done by robots in cooperation with 51,000 reliable employees. The same pursuit that guided Toyota and Mercedes, but now rendered in digital code. The machines do not imitate human effort. At Mercedes in the 1980s, such alignment depended on craftsmanship. At Toyota, it depended on teamwork. Here, it depends on vision sensors and pressure algorithms, mechanical intelligence that never tires, never blinks. The blue light reflects off flawless metal, each arc precisely timed to the millisecond. The human role has shifted from builder to overseer. Every motion is pre-programmed, every angle calculated. It's the perfection of predictability. To store so many cars, they have created the Autostadt, an automobile town. 2 60-meter-high towers, each of which holds 400 brand-new cars. The cars enter through an underground tunnel. They are lifted by a hydraulic hoist at 1.5 meters per second and stacked on shelves. Car number 4,500 leaves the factory and takes its place in the Autostadt. Today's plan is fulfilled, and a new production day begins at Europe's largest factory. The evolution is complete. This is not merely a factory. It is the manifestation of an era where engineering, data, and aesthetics merge into one continuous language of perfection. The new chapter of European manufacturing begins not with noise, but with rhythm. Inside Škoda's stamping hall, robotic arms glide like synchronized dancers, lifting cold sheets of metal with effortless precision. A massive press descends. The metal folds under thousands of tons of force. Stamped panels travel down twin conveyor belts, guided by sensors and monitored by technicians in pale uniforms. A forklift driver brings a crate of stamped panels, while machines position them for assembly. Crates stack toward the ceiling, a metallic archive of future vehicles. Deeper inside, the camera descends into the welding hall, a forest of yellow robotic arms. They move in waves, aligning, gripping, fusing, transforming dozens of cold panels into a living structure. Here, the choreography becomes denser. Robotic arms converge over a single frame, welding sparks invisible beneath insulated sleeves. Here, a chassis frame begins to take shape. Clamps, sensors, and laser welders move together, guided by thousands of invisible calculations. The line no longer assembles, it creates. Welding arms dive toward the frame in unison. Electric pulses melt steel with surgical control, forming joints stronger than the metal itself. The half-finished structure slides forward, steel still warm, shape still uncertain. From a side view, an arm delicately retrieves the finished chassis section and positions it into storage. In a multi-level assembly tower, robots now work vertically, lifting structures through layers of production. And finally, the camera returns to the main welding hall. The car's skeleton, once fragmented and scattered, now unites into a single coherent form. Next, the frames glide deeper into the production line. Here, surface preparation begins. Smoothing, cleaning, and coating each millimeter of steel before paint application. In this stage, even microscopic imperfections are eliminated. Steel geometry transforms into a living body of motion, ready to be painted, wired, and given purpose. Škoda's factory stands as a testament to Europe's silent revolution. Finally, the bodies move into the painting corridor, first through sanding and inspection, then into fully sealed paint booths. Robotic sprayers work in harmony, layering protective coatings with flawless uniformity. Human operators monitor every parameter, temperature, flow, and finish, ensuring that every Škoda leaves the line in showroom perfection. At Toyota, timing was a human art. Here, it is a digital instinct. The robots do not communicate with words, but through code, precise, unerring, and invisible. Now, it's the output of simulation software predicting not just how the car will look, but how it will perform, how it will age, how it will survive. The factory no longer guesses, it knows. Human hands now inspect, not build, verifying a process that is already perfect 9,000 times out of 10,000. The green Škoda emblem above the hall glows faintly, watching over a new generation of precision, distinctly Czech, but born from a German blueprint and Japanese discipline. What Mercedes once achieved through craftsmanship and Toyota through process control, Škoda now accomplishes through predictive engineering. The painted body emerges from the curing chamber, a mirror of steel and light. Here, every surface gleams under sterile illumination. It no longer looks like raw material, it looks alive. This is the birth canal of modern manufacturing. Now, human expertise returns. A technician polishes the roofline with quiet focus, the movement both mechanical and personal. The machines may ensure accuracy, but humans ensure beauty. The subtle transition from manufactured to crafted. Another hand takes over, this time wielding a microscope. The inspection is not visual, it is forensic. Every micron of paint thickness, every reflection distortion, is documented. A gloved worker presses emblem letters onto the rear, transforming anonymity into identity. This act, simple yet symbolic, marks the moment when data becomes design and a machine becomes a car. Inside, technicians fit the first layers of wiring and insulation. The interior is still hollow. Two men coordinate, one holding the controller, the other aligning the interior roof module. Hands connect components under the dashboard, a tangle of cables, levers, and silent complexity. What seems chaotic is, in fact, an orchestration of ergonomics and function, refined through decades of iteration. Technicians work in perfect rhythm, threading kilometers of electrical wiring through the car's frame. The roof lining is carefully fitted, soft materials meeting hard steel, a process that demands both strength and delicacy. Every module, from lighting panels to sensor clusters, is positioned with surgical accuracy. Even in a world ruled by automation, the human touch remains irreplaceable, guiding each piece into its rightful place. The line stretches endlessly, a living organism of production. Windshields are mounted next, sealed perfectly by skilled technicians. The process looks effortless, but every millimeter matters. The glass not only protects, but strengthens the vehicle's frame. Each Škoda leaves no room for imperfection. Workers inspect the alignment, their eyes and instruments working as one. Beneath the factory's white light, nothing escapes attention. The reflection on the glass must be flawless, the surface untouched by error. Meanwhile, the engines await their destiny. Rows of power units, meticulously assembled, tested, and approved, stand ready to merge with their matching chassis. Every one of them a product of precision, built to endure years of movement and miles of road. Wheels are added, the final gesture that gives life mobility. Seats arrive, wrapped and protected. At the dashboard, a worker aligns the steering wheel. Doors close softly as automated torque arms secure them with practiced consistency. Every hinge, every latch is tested, because the sound of a closing door speaks volumes about quality. The Škoda factory stands as the bridge between eras, from industrial repetition to intelligent collaboration. And in this balance, the car takes on its final meaning, not just built, but understood. Below the assembly line, frames await their pairing. Cables, exhausts, suspensions, all in their rightful place. The car descends slowly. The choreography between upper and lower lines forms the heartbeat of the factory. Headlights are installed, the car's eyes. A worker fits them with care, ensuring perfect alignment. Soon, they will pierce the darkness of real roads, carrying stories yet to be written. The line stretches endlessly, the future repeating itself, one car at a time. Škoda has reached a point where production is not just about making vehicles, but about refining intelligence. From Toyota's human harmony to Volkswagen's algorithmic order, this is the next step. Manufacturing that learns. The machine no longer just obeys, it anticipates. Now the car moves forward under the glow of bright inspection lights. Technicians open and close each panel, inspect seams and switches, verifying that the vehicle not only functions, it feels right. This is the last human contact before the car meets the world. And finally, a line of completed cars stretches into the distance, each one identical in design, yet destined for a different story. From molten steel to refined precision, from blueprint to motion, this is the evolution of craftsmanship in its purest form. From the age of craftsmanship to the age of consciousness, what began as the hum of assembly lines has become the whisper of artificial intelligence. At Tesla's Gigafactory, a new kind of vehicle awakens. No driver, no key, no human hands required. Once assembled, it rolls off the production line under its own command, guided by sensors, cameras, and a neural network trained on billions of real-world miles. Through factory gates, the car maps its surroundings, identifying every cone, every curb, every stop sign. It communicates silently with satellites in the Tesla fleet cloud, updating its awareness in real time. Every turn, every brake, every acceleration, calculated with mathematical precision and the calm certainty of code. This is not just motion, it's autonomy in its purest form. From the Gigafactory floor to the open road, the car navigates traffic, merges onto highways, and continues toward its destination, the customer's home. There, it parks itself, shuts down, and waits, ready for the first human touch it will ever receive. A century ago, cars depended on hands, pedals, and instinct. Today, they depend on algorithms, sensors, and foresight. Mercedes-Benz is taking another bold step into the future of automotive manufacturing by testing Apollo, a humanoid robot from Aptronic, inside its production line. Unlike traditional robots locked in place, Apollo is mobile, adaptable, and designed to work alongside people, not replace them. It takes on the heavy, repetitive, and physically demanding jobs, lifting, carrying, and positioning parts, while human workers focus on precision and design. Mercedes engineers are experimenting with how Apollo handles material transport, logistics, and assembly, all while navigating freely through the factory. If the trial succeeds, Apollo could become a cornerstone of the smart factory era, where artificial intelligence and human skill operate in perfect sync. This is more than automation, it's collaboration, a vision of the future where technology enhances craftsmanship and innovation keeps Mercedes at the forefront of intelligent manufacturing. Stay tuned for more breakthroughs from the factory floor. And don't forget to like, subscribe, and hit the bell for the next evolution in automotive technology. And now, at BMW's Spartanburg plant, the future takes form. Humanoid robots, called Figure 02, are the newest workers on the floor. Their arms mimic human flexibility. Their fingers handle metal parts with delicacy, once impossible for machines. They lift, position, and secure components alongside industrial robotic welders. AI models track their every movement, learning, adapting, optimizing. In one frame, a Figure 02 studies alignment before locking a part into place. Another robot observes, waiting for the next step. Nearby, traditional robotic arms continue welding. Sparks flying, yet now coordinated with their human-shaped counterparts. This is not mere automation. This is machine collaboration, a system where robots not only repeat, but think, feel, and refine. From the roaring presses of Fiat Lingotto to the silent sensors of BMW's AI-driven line, the automobile's birthplace has transformed into a laboratory of cognition. Factories no longer just build, they learn. From Fiat's rooftop track to Tesla's self-driving departure, From Moskvich's endurance to BMW's learning robots, each phase captures an evolution not just in machinery, but in mindset.